Geometry, the study of shapes and sizes, is one of the oldest branches of mathematics. For centuries, the work of the ancient Greek mathematician Euclid was considered the gold standard in geometry. His book Elements laid out a set of axioms and postulates that were thought to be self-evident truths about the properties of space. However, in the 19th century, two mathematicians, Lobachevsky and Bolyai, independently discovered a different type of geometry known as non-Euclidean geometry that challenged the long-held beliefs about the nature of space. See with your own words. Lobachevsky was born in Russia in 1792 and began his studies in mathematics at Kazan University. He was fascinated by Euclid's Elements and spent much of his early career trying to understand its underlying principles. In 1826, while working on a problem related to the parallel postulate, the fifth postulate of Euclid's geometry, he stumbled upon a startling discovery. He realized that it was possible to create a consistent system of geometry in which the parallel postulate did not hold true. In other words, in this new system, there could be multiple lines passing through a point that are parallel to a given line. He published his findings in the paper Geometria in 1829, but it received little attention. János Bolyai, born in Hungary in 1802, was also captivated by Euclid's geometry from a young age. He too was working on the parallel postulate, and in 1823 he also discovered a non-Euclidean geometry in which the parallel postulate did not hold. He published his work in 1832 in the appendix of his father's book Tentament, but it was also overlooked. Both men were working independently and unaware of each other's work, but their discoveries were groundbreaking. They had shown that there were other consistent systems of geometry in addition to Euclidean geometry, and that the Euclidean geometry was just one of many possible geometries. Their work laid the foundation for the development of non-Euclidean geometries, which would have a profound impact on mathematics and science. The discovery of non-Euclidean geometries was not immediately accepted or understood by the mathematical community. Many mathematicians and scientists of the time believed that Euclidean geometry was the only true geometry and that non-Euclidean geometries were a mere mathematical curiosity. However, over time, the work of Lobachevsky and Bolyai began to gain more recognition and acceptance. In the decades that followed, non-Euclidean geometries were developed further by other mathematicians, including Bernhard Riemann and Felix Klein. They realized that the non-Euclidean geometries could be used to model the geometry of the universe, and they began to explore the implications of these new geometries for physics and cosmology. The discovery of non-Euclidean geometries had a profound impact on the field of mathematics and science. It showed that there were multiple consistent systems of geometry, and that Euclidean geometry was just one of many possible geometries. It also paved the way for the development of new branches of mathematics, such as topology and differential geometry. In conclusion, the discovery of non-Euclidean geometries by Lobachevsky and János Bolyai in the 19th century was a revolutionary moment in the history of mathematics. Their independent discovery of non-Euclidean geometries opened the door for the development of new branches of mathematics. Their contributions to mathematics continue to shape our understanding of the world today.